In this video, I'm going to explain very briefly what the mean variance rule of investing is in introductory finance and illustrate the important concept with the help of a numerical example. So this mean variance rule of investing was first developed by Harry Marquez in early 1950s, for which he was awarded Nobel Prize in Economics in 1990. The theory Harry Marquez developed is popularly known as mean variance portfolio theory. Since I don't want to discuss this in extensive fashion, therefore I have just said here mean variance rule. So I want to extract the key element of this portfolio theory and explain it here. So this theory provides the mathematical basis for the statement, don't put all your eggs in one basket. And you have heard that, right? So this theory teaches us about the diversification rule in the investment. So this theory is also the basis for portfolio management. So when this theory was first proposed, it was a revolutionary idea because before that time there was no systematic approach of portfolio management, and after the introduction of this portfolio theory, people started this as the beginning of the modern portfolio management of the money. Later, other economists built some other theories based on this mean variance rule. For example, the capital asset pricing model is very important asset pricing model in finance, and that CAPM is built on the idea behind this mean variance rule. So it clearly shows that the mean variance rule is very important in finance. Therefore, I would like to provide you a cursory introduction about this mean variance rules of investing. So there are two key assumptions we should be aware of about this mean variance rule of investing. The first one is investors like portfolio with high expected return and dislike portfolios with high risks measured by standard deviation. So that's the first assumption. The second assumption is that investors can borrow and save at the risk-free rate. With these assumptions, the mean variance rule of investing states that the optimal portfolio of risky security for an investor is the one that has the highest expected portfolio excess return per unit of risk taken. That means the best portfolio of risky security is always the one that maximizes the Sharpe ratio. That means we can compute the best portfolio or the optimal portfolio for any investor by maximizing the Sharpe ratio, because Sharpe ratio measures per unit excess return for the risk you take, right? Therefore, if you can maximize the excess return per unit of risk taken, then that is the best portfolio. So this is the essence of mean variance rule. That means any investor who likes higher return and dislike high risk and who can borrow and save at the risk-free rate, then the best portfolio for him is always the one that has the maximum Sharpe ratio. This graph helps us to understand the meaning of mean variance rule of investing. And in this graph, I have portfolio frontier, assuming that I have two risky assets, stock A and stock B. And if you don't know what this portfolio frontier is, please watch another video where I have explained how to plot the efficient portfolio frontier. And in this portfolio frontier, this purple dot is called the global minimum variance portfolio, and the portfolio frontier below this global minimum variance portfolio is called inefficient portfolio frontier, and the portfolio frontier above the purple dot is called the efficient portfolio frontier. So the mean variance rule tells us that of all the points on this efficient frontier right here, which one is the optimal portfolio of risky asset, or in a way, which one is the best portfolio of risky assets. And in this graph, this red dot is the best portfolio or the optimal portfolio of risky assets, and that is also called the tangency portfolio. So how do we compute that best portfolio? And no matter the risk preference of investor is, everybody holds that tendency portfolio because that is the best portfolio for any investor. So how do you get this tendency portfolio or the best portfolio? This is always going to be the tangent line drawn from the risk-free asset rate to the efficient portfolio frontier. So in a way, we can obtain this line by maximizing the Sharpe ratio, which is the excess return of portfolio divided by standard deviation of the portfolio. So if you maximize this Sharpe ratio, then you will be able to get the best portfolio or the optimal portfolio of risky assets. So every investor should hold this best portfolio or the optimal portfolio of risky assets. So this is the mean variance rule of investing. What this mean variance rule assumes that the investors can borrow and lend at the risk-free rate. Therefore, every investor is better off by combining this best portfolio with the risk-free asset, because risk-free asset is not correlated with the risky portfolio, as well as risk-free asset standard deviation or the variance is zero. That means there is no risk involved in the risk-free asset. Therefore, every investor will be better off if they combined risk-free investment with the risky investment. So once you make that assumption, then this green dotted line becomes the portfolio frontier or the efficient portfolio frontier. So any line that you draw from your risk-free asset and tangent to the efficient frontier of risky portfolio, then this tangent point is the best portfolio or the optimal portfolio of risky assets. And now green dotted line is the efficient portfolio frontier, and where the investor will be investing, meaning what proportion of money will be invested in the risk-free asset and what proportion of money will be invested on the best portfolio, will depend on the risk appetite of the investor. If the investor would like to take more risk, in that case they would borrow money at the risk-free rate and put more money on the risky portfolio. In that case, they would be somewhere in the upper part of this efficient portfolio frontier. And if the investor doesn't like to take much risk, then what they can do is they would like to put more on the risk-free and less on the tendency portfolio, and they would be somewhere towards the lower end of the portfolio frontier. And remember this green dotted line, which is the efficient portfolio frontier when there is a presence of risk-free asset in the market, and that is also called the capital market line. And this concept is very important later when we try to understand the CAPM model. Now what we would like to do is we would like to go and do a numerical example to illustrate the concept of this mean variance rule of investing. And I have this example right here, and that example says consider a portfolio that consists of two stock, right? Apple and Nvidia. So it is asking what is the weight on each stock in the optimal portfolio. And the second question is asking if you were to invest 25% of your fund into T-bills, meaning risk-free rate, and the remaining fund in your portfolio of risky asset, what would be the expected return of this portfolio? And in order to answer this question, you have to use monthly adjusted closing price from August 2012 to July 2017 and average 13 weeks treasury bill rate as the risk-free rate for the same time period. So let's go and do this problem. So in this Excel file, I have historical stock price for Apple and Nvidia as well as yield on 13 weeks treasury bill rate, all downloaded from Yahoo Finance for the period August 2012 to July 2017. And I'm going to use this data set in order to compute optimal portfolio of risky asset, and the risky asset being Apple stock and Nvidia stock in this case. So before I go and compute, I need to first compute the return series. So you know how to compute return on each stock. So I have already computed. One adjustment I have made is here about this yield on treasury bill rate. The yield on treasury bill rate you download from Yahoo Finance is on annual basis, not in a percent. So in order to convert that into a monthly basis and in percent, you have to divide this given yield on 13 weeks treasury bill rate by 1200. So that I have done here. So once you have all this return on a monthly basis, now you can go and compute first average return, because I need this average return to compute the portfolio mean and the variance, right? So once you compute for one, you can drag it to the right and get for the next. And now I want to compute the variance for each stock. So I can compute the variance. And once you compute the variance, you can go and compute the covariance for these two stocks. So it's going to be COV covariance, and choose sample one and covariance of these two stocks. So you have to choose the return series of these two stocks, first series comma the second series. So that gives us the covariance, right? Once you compute covariance, now you need to compute portfolio mean and the portfolio standard deviation. To compute the portfolio mean and the portfolio standard deviation, I need the portfolio weight. So I want to start with 0.5 because that's the easiest way to start. And I also need this sum of the portfolio weight to be equals to 100. So I'm gonna need this later. So I'm gonna write this equals to this guy plus this guy is right here, which is 100%, meaning 100% of money is being invested on these two stocks. So with this given, now I can compute the portfolio mean, right? So portfolio mean equals to proportion of money you put on Apple stock times the average of Apple, right? Plus proportion of money you invest on Nvidia stock times the average of Nvidia stock. So that gives me the portfolio mean. Now you can compute portfolio variance, and I assume that you already know how to compute portfolio variance. So I'm going to do this here, equals to square of the proportion of money you put on Apple stock, right, times the variance of Apple stock plus square of the proportion of money you invest in Nvidia stock times the variance of Nvidia, right, plus 2 times the proportion of money you invest on Apple stock times the proportion of money you invest in Nvidia stock times the covariance. So once you have all that input, you can put enter, and that gives you the portfolio variance. And once you have the portfolio variance, you can compute the portfolio standard deviation. So it's going to be square root of the portfolio variance. That gives us the portfolio standard deviation and risk-free rate. And we are assuming average monthly risk-free rate as a risk-free rate. So I'm going to calculate the average of this monthly risk-free rate, right? So that's the one we are going to use to compute the Sharpe ratio, and now I need to compute the Sharpe ratio. And remember again, the Sharpe ratio is always equals to here the portfolio mean return minus the risk-free rate, right, over the standard deviation of the portfolio. So these are all the input I need in order to compute the optimal portfolio of risky assets. So remember that in order to compute the tendency portfolio or the best portfolio or optimal portfolio risky asset, we have to maximize the Sharpe ratio subject to the weight constraint, right? So we need to compute the Sharpe ratio. That's why we had to compute all of these inputs here, and finally we have the Sharpe ratio, right? So let me change that color to yellow. So what we have to do is we have to maximize this Sharpe ratio by changing weights. So if you do that, and whatever resulting portfolio mean and the portfolio variance will be, that will be the optimal portfolio of risky assets. So I'm going to use Excel solver function in order to compute that. So go to data and then click on solver, and it has a different options we have to choose. First, you have to choose the objective. What is your objective? Meaning we want to maximize Sharpe ratio, right? So I'm going to click this arrow here and select this guy here, portfolio Sharpe ratio, and whether you want to maximize, minimize, or value of. Since we want to maximize, click on maximize. So what do you want to change? And in this case we want to change the portfolio weights, right? So how much money you put on each stock, that has to be changed. These are the changing cells. Now finally I need to also input this weight constraint, which is sum of these two weights should be equals to 1 or 100%, right? So I can add here the sum of these two guys here, which I have already written right here, right? That should be equals to 100% or 1, right? So once you input all these input for your solver, and there's one more option you can choose, make unconstrained variable non-negative. So you can click on this right here. If you click it this, then the weights will always be positive, and if you don't put the tick sign here, the weight could also be negative, but I think in our case it won't make difference. But if you have a lot of stocks in your portfolio, it might make difference. And I'm not I'm unchecking right here and click solve. So once you click on solve, now your portfolio weights on these two changed, right? So the portfolio weight on Apple is going to be 0.0066. If I put that in a percent, it is going to be less than 1%. But if now on the Nvidia one, it is 99% or little over 99%. And this is, I think, is because of the data bias here. If you look at the average return of Apple for that period is 1.12%, whereas Nvidia is 4.48%. Therefore, more money is being invested on Nvidia, less money on Apple. So the Sharpe ratio right now is the 47%, and the portfolio mean, like here, the portfolio mean you obtained by maximizing Sharpe ratio is the portfolio mean, or the optimal portfolio of these two stocks. And the standard deviation that you have here is the standard deviation of optimal portfolio of risky asset, because as soon as this Excel solves this, it will change the weight, and once the weight changes, the earlier portfolio mean and the portfolio standard deviation will change. So that is the optimal portfolio of risky assets. Okay, so once you compute the optimal portfolio of risky asset, and the last part of the question says, okay, if you invest 25% on the risk-free rate, and the remaining 1 minus 25%, which is 75% on your risky portfolio, what is going to be the expected mean? Remember, the expected return of a portfolio equals to proportion of money you put on stock A times the average of stock A plus proportion of money you invest in stock B times the average of B, right? So in this case, proportion of money spent or invested on risk-free rate, right, times the average risk-free rate plus proportion of money you invest on risky asset times the portfolio mean of the risky asset, in our case 4.56. So if you do this and hit enter, and that gives you the expected return of a complete portfolio, and I can change the format, and for now it's 16 decimal places. Now I can do just 4, and now it has 3.4211. So this is how you solve this. And let me recap here. So we were trying to illustrate how to compute the best portfolio given the information, and we followed the process that we computed return, and we had to compute the Sharpe ratio because we had to maximize that. In order to compute Sharpe ratio, we had to compute average of each stock, variance of each stock, and covariance, because we need all of them to compute portfolio mean and the portfolio standard deviation. And once you compute portfolio mean and the portfolio standard deviation, you can compute the Sharpe ratio. And once you compute Sharpe ratio, then you can use Excel solver function in order to maximize Sharpe ratio and get the new weights, and that new weight gives us the optimal portfolio of risky assets. And I hope it makes sense. Thank you.